Hi everyone, welcome back to another Planetarium live stream. My name is Jessica, I am the director of the Planetarium, and with me is a familiar face, and at least a familiar voice, now that he is finally showing his face, but I'll let him introduce himself.
I'm Eli. I'm a physics student at UMD.
So tonight we are going to be going on a journey through the solar system. If there's anything in particular that you'd like us to stop and see, or any questions you have, leave them down in the comments. Eli will be watching those and will let me know if there are any special requests. But with that, I'm going to get switched over. So the program we're using tonight to tour the solar system is called Celestia. It is a free-to-use program. I have the link in the video description if you're interested in downloading it and exploring for yourself. And since we are doing a tour of the solar system, I figure we'd start with a kind of overall look at our solar system. Our solar system is full of a lot of different things. We have the, of course, sun at the very center. We have 8 planets. We have asteroids and comets and Kuiper Belt objects and dwarf planets, and there's a whole lot of stuff out there. But everything is held in place by the sun, which is our closest star and sits at the center of our solar system. Now, the sun is a star, like I just said, like every other star that we see up in the nighttime sky. It's just a lot closer to us, which is why it looks a lot bigger and brighter. You may also notice that the sun here has a few dark spots. These are what we call sunspots because they're spots on the sun. Yeah, we're not always clever when we come up with names, but these sunspots are areas on the sun that are a little bit cooler than the rest of the surface. And when I say a little bit cooler, I don't mean that it could be like cool to the touch. So the surface of the sun is about 10,000 degrees Fahrenheit. Those little dark spots, yeah, they're only about 7,000. So a little bit cooler, but still very, very hot. But that is why they look darker. All right, well, let's head on to our main event, our tour of the planets of the solar system. And we are going to start with the closest planet, and that is the planet Mercury. So here we are. This is little Mercury. Mercury is about a third the size of our Earth, and it may look like another familiar object. Yeah, it kind of looks like our moon, and that's because Mercury and the moon are actually very similar objects. They're both these big balls of rock in space, big enough that they can pull themselves into a sphere or a ball shape, but small enough that they don't have an atmosphere and they don't have any volcanoes or plate tectonics or running water or wind to erode the surface. And so what we end up seeing is this gray rock that is covered in craters from where it's been hit over and over and over again over the 4.5 billion years that the solar system has been around. Now, the Earth has been hit a lot too. It's just we have those things that I was talking about, volcanoes, plate tectonics, erosion, and that repaves and grinds down the surface of the Earth, so those craters disappear. They don't last long. And so the number of craters can actually tell us about an object and tell us how active it is. Now, Mercury is so small that it does not have an atmosphere. That's another reason it's hit and has so many craters. There's a lot of things that could hit the Earth actually burn up in our atmosphere. And since Mercury is the closest planet to the Sun, it gets pretty hot. Daytime temperatures on Mercury can reach up to, I believe it's 700 degrees. So, pretty warm, but that's only in the daytime. Since Mercury doesn't have an atmosphere, the nighttime side can't hold on to that heat from the daytime, and it cools off very quickly. And so nighttime on Mercury drops down to like negative 200 degrees. So you're either going to be really hot or really cold, depending on if you're in daytime or nighttime. All right. So our next visit is going to be to the second planet from the Sun, and that is Venus. So Venus is often considered a twin of Earth's. We often call it our like sister planet, and that's just because Venus is kind of the same size as Earth. It's made up of a lot of the same materials. And we thought for a while that maybe it was a lot like the Earth. And we couldn't tell at first because, as you can see here, Venus is covered in a thick layer of clouds. So thick that we can't see down to the surface. And so it wasn't until the 60s when we developed radar technology that we were able to peer through these clouds and get a view of the surface. And oh boy, it is nothing like Earth. Because of those thick clouds that we saw, that acts as a really thick blanket and traps a tremendous amount of heat underneath those clouds. It traps so much heat that Venus is actually hotter than the daytime temperatures on Mercury, with temps reaching almost 900 degrees, which is hot enough to melt metal. It's crazy. And so we have this scorching hot desert, no water in sight, volcanoes, volcanic flows, and those clouds that we saw, yeah, they're clouds of sulfuric acid, so it, rains acid. This is not at all Earth's sister, not at all maybe our evil stepsister, but it's not our twin. And so that is our evil stepsister. I like that. We're going to go with that from now on, of Venus. Now, we have actually landed some spacecraft here. They only lasted for about an hour before the temperatures and acid and pressures destroyed it, but that did give us views of the surface, and that's pretty awesome. All right, heading on to the third planet from the Sun, the one that we know best because it's our home, the planet Earth. Looks quite a bit different than the other two planets we've seen so far. We have clouds like Venus, but not as thick as Venus's clouds are. We have liquid water on the surface, a lot of it. We have life on the surface, which we haven't found anywhere else. And so that makes us pretty unique and special. But that also means that unlike the other planets, we have something that's actively working against the natural way of things. Us humans are, upsetting the balance a little bit. And so that's something that we're just going to have to be careful of because this is our only home planet for now. And we haven't figured out anywhere else we can go yet. Now, Earth is the first planet that we have come to that has a moon. Oops. Let's try and click on it. Here we go. So Mercury and Venus do not have moons, but we do. And it is our constant companion as it orbits around the Earth. Again, looks a lot like Mercury, that kind of big gray ball of rock that is covered in craters. And we can see lots of them for the same reasons. Unlike Mercury, though, we see some of these dark patches that we don't really see on Mercury. They're really evident over here, which is a little bit more difficult to see because this side is currently in nighttime, but you can still see them there. Those dark patches are what we call the lunar maria, which is Latin for sea. Maria is Latin for sea. And that's because before we had telescopes, we thought that, hey, maybe that's a body of water up there. Turns out it's not, it's rock, but the name stuck, as things often do. But these are actually ancient lava flows. So the moon, back a long time ago when it was really young, did have volcanoes. It had active lava flows. And those lava flows flowed over the surface and repaved that area of the moon and created these darker, smoother patches across the surface. All right. So heading on out some more to the last of our rocky planets sits good old Mars, the red planet. So Mars is called the red planet because of exactly what you see here. It's red in color. And that red color comes from rust, iron oxide. There's a lot of iron in the soil and the rocks, and any oxygen that comes into contact with it immediately causes rust. And so we have this rusty surface that gives it this red color. Mars, also you can see a little bit of a polar cap down there, and we can see one up in the north. Mars does have polar caps like the Earth does. And some of that polar cap is water ice, although a big chunk of it is actually frozen carbon dioxide or dry ice. Mars has a few really cool features that we want to look at, but they are currently in nighttime. So I'm actually going to speed time up so that Mars has can spin around for us and show us some of the cool things to see. So right here, we have a giant volcano known as Olympus Mons. This is actually the largest volcano in the solar system. And it's so big, it's 3 times taller than Mount Everest, the tallest mountain on Earth. And if it were to be sat somewhere on Earth, it would cover up the area equivalent to the state of Arizona. An absolutely massive volcano. Now, down next to it are a few other volcanoes that are quite large as well. Mars has a lot of them. They're not active anymore, we don't think, because we haven't seen any indication that they're active, but it's possible that they are over like 100 millions of years of time scale. We haven't seen anything since we've been watching closely. Now next to it is this big gash across Mars known as Valles Marineris. This is a canyon, much like our Grand Canyon, except even grander, if you could believe it. This canyon would actually stretch across the entire United States, and in some places is 4 times deeper than the Grand Canyon here on Earth. So just some absolutely massive features here on Mars. Now I told you that those polar caps that we see do have some water ice. We have also found that there is some ice frozen underneath the ground. But when we look at the surface, we can see features kind of like this that look almost like rivers, dried up riverbeds. And we actually find a lot of these across the surface. And we have found so many of them, as well as minerals that only form in the presence of liquid water, that we are very confident that sometime in the past, Mars was very different, more Earth-like than it currently is. It was a lot warmer, it had lots of liquid water flowing across the surface, and was quite a different place than it is today. So Mars does have 2 moons, Phobos and Deimos, and we'll go take a look at, oops, come here, little Phobos. Oh, I had it. This is the problem with, oh my goodness, there we go. All right, let's go see little Phobos. So Phobos is quite a bit different than our moon. I lovingly call him a lumpy space potato because, well, look at him. It looks like a lumpy space potato. So it's not nice and spherical like our moon is, and that's just because it's so much smaller. And essentially, Deimos looks exactly the same. And both Phobos and Deimos look an awful lot like asteroids. And that's actually what we think they are. We think that they are a couple of asteroids that got just a little bit too close to Mars, and Mars's gravity was able to grab onto them and hold on tight and cause them to orbit around Mars instead of orbiting around the sun. And that's not that too far-fetched. Sitting in between Mars and our next planet, Jupiter, is this big region called the asteroid belt, where hundreds of millions of asteroids live. And so, Mars is pretty close. It's not that surprising that a couple of asteroids ended up, attaching themselves to Mars. All right. So speaking of Jupiter, let's head on out that way. You will notice as we fly in that there are quite a few of these tealish green lines around Jupiter. Let me reorient ourselves. All of these lines that we're seeing here are moons. Yeah, Jupiter has, what's the number? 79. 79 moons. Or at least that's the current count. It's got quite a lot of them. Now, most of them are lumpy space potatoes, but there are a couple of really interesting ones that I'm going to show you in a little bit. But first, Jupiter. So Jupiter is the largest planet in our solar system, so large that it actually would take 10 Earths lined up side by side to stretch from one side to the other across the diameter of Jupiter. And so Jupiter is what we call a gas giant. Now, I know you've probably heard this term and immediately makes you think that it is a big ball of just gas. Because why else would you call it a gas giant? And I actually have to tell you that that's not quite correct. It is a big ball of hydrogen, mostly, but that hydrogen is predominantly a liquid hydrogen, not a gaseous hydrogen. And so when we started calling these gas giants, we meant it as a description of the element rather than the state of matter that was there. And so it's probably more accurate to call it a liquid giant rather than a gas giant. But the upper area we're seeing right here is the atmosphere, which is gaseous. And we see lots of these pretty swirling bands of clouds. Most famous on Jupiter is the big red spot, because it's a big red spot. Remember, we're not always clever. This is actually a hurricane on Jupiter, large enough that you could fit about 2 to 3 Earths inside of that. And it has been raging on for over 150 years. Not 100, 350 years. Over 350 years. For as long as we have been looking at Jupiter through a telescope, we have seen this giant hurricane. And we don't quite know why it lasts for so long. But it apparently has been. And that's one of the things we're still trying to figure out. All right. So let's go see a couple of the moons that I was telling you about. Let's see if I can find them without bringing up another guide. Oh, there you are. Right there. Okay. So first up is the moon Io. Io has the hilarious nickname of being the pizza moon because it kind of looks like a pizza, right? You got that red sauce and yellow and white cheese and some black spots that, I don't know, Eli says they're olives, but I think olives are disgusting and he's crazy. So I say they're sausage.
Whoa. Oh.
Did I just start something?
You might have.
Well, you can make your pizza moon, whatever toppings you want. How about that?
Sounds good.
But what's really cool is all of these black specks that you're seeing are actually volcanoes. Io has over 150 active volcanoes. That's way more than we have here on Earth. And that's kind of crazy because Io is actually about the same size as our moon. And we see our moon doesn't have any active volcanoes, let alone hundreds of them. And so it turns out that Jupiter and the other moons around Jupiter are to blame for this. So we have Jupiter on one side, that's tugging Io towards it. And then we have the other moons on the other side, tugging Io out the other way. And so it's getting tugged back and forth and back and forth. And as it does so, that causes the rocks inside of Io to rub against each other. And just like when you rub your hands on a cold morning to warm them up, that rubbing back and forth of the rocks causes the rocks to heat up. And it generates so much heat and energy that it has to escape somehow, and it escapes as volcanoes. And that's why we have such a crazy active moon here around Jupiter. So the second moon that I want to take you out to see tonight is one of my personal favorites. There we go. And let's see if I can find it in this crazy mess. You should be right out here. There you are. Let's see if I can click on it. Ha! Second try. That's not too bad, right? So the next moon I want to take you to is Europa. Now, Europa, unlike Io, is not a land of volcanoes. It's actually a land of what looks like ice, because the surface of Io is covered in a thick layer of ice. But it's not perfectly smooth. We can see that there are these stripes across that look kind of like someone's been ice skating, but those are actually cracks in the ice because Europa, just like Io, is caught in a similar tug of war between Jupiter and the other moons. Now, since Europa is further away than Jupiter is, anyway, since Europa is further away from Jupiter than Io is, this tug of war isn't as extreme. And so the inside is still kind of heating up, but not as much as Io was. But it is heating up enough that underneath this thick crust of ice, we think sits an ocean of liquid water. And not just a measly little ocean. We actually think Europa's ocean might contain twice as much water as we have here on Earth, which is absolutely insane. That is a tremendously large, deep ocean. And that has astronomers very excited because one of the things we think that life must absolutely have to develop is liquid water. And here we have a world with a lot of it. And so we're excited to one day in the future send a mission to explore that ocean underneath the icy crust and see what might await us. And that mission is in the works. They are currently planning it out, and I hope it happens in my lifetime. I will be very happy to see that little submarine swimming around in Europa's oceans, but we'll see what happens. All right, heading on out past Jupiter is our next planet of Saturn. Saturn, you can see here, also has quite a few rings, or quite a few moons. Saturn is actually the reigning champion of moons with a grand total of 82. Yeah. Saturn is most famous for its beautiful ring system, although it's actually not the only planet to have rings. Jupiter, Saturn, Uranus, and Neptune all have rings. It's just Saturn's are the biggest and the brightest, and the easiest to see through a telescope here on Earth. So they're the first ones discovered and kind of the most famous because of that. But all of the outer planets do have rings. And these rings around Saturn are not solid like a racetrack. They are hundreds of thousands and millions of pieces of ice and a little bit of rock that are all orbiting around Saturn. And so it's basically a big debris ring circling the planet. So Saturn has these really pretty cloud stripes, just like we saw on Jupiter. We can also see when I get kind of edge on like this how thin the ring system is. And among all of these moons sit a couple of really interesting ones. So I'm going to start with Enceladus because it's the first one that I saw. And Enceladus is a lot like Jupiter's Europa. We see an icy crust. Down here, we see some cracks where we actually see jets of water vapor that shoot out from these cracks, telling us that, like Europa, there is an ocean of liquid water underneath this icy crust. And so we are excited, again, as this moon could be another possible world where life has developed because of that ocean of liquid water that lies underneath there. All right. So the last moon, and let's see. Did I do? Oh, I did Jupiter. My bad. I'm still learning some of these keyboard controls. All right. So the last one that I want to take you to see around Saturn is Titan. So Titan is actually the largest of Saturn's moons, and it's the second largest moon in the solar system, sitting just behind Jupiter's moon Ganymede. It's such a large moon that it's actually larger than the planet Mercury. It's quite a big moon. But what's interesting about this moon is the fact that it has an atmosphere. And that's what we're seeing here. It has an atmosphere thick, full of clouds, actually about 1.5 times as thick as Earth's atmosphere. And it's the only moon to have one. And that in and of itself makes it quite special. But then when we look on the surface of Titan, we see that there are, we come over here, these dark patches near the poles, which actually turn out to be lakes of liquid. Now, not liquid water, because liquid water, it's too cold on the surface for that. In fact, the surface is frozen water ice. But this is probably liquid methane or ethane. And so while it's not water, who's to say some different type of life may not develop or may develop that depends on liquid methane instead of liquid water? And in fact, we have a new mission that is heading out to Titan. Its name is Dragonfly, and it's a little quadcopter because there's an atmosphere. We can fly around, and that's going to let us explore a lot more of its surface in a much shorter amount of time than an ordinary rover would be able to. And so that's going to be really exciting. All right, so we have 2 last planets to go visit. Next up is the planet with the funny name, Uranus. Now I have to tell you though, this isn't the planet's original name. It was discovered by an English astronomer named William Herschel. And as any good Englishman, he knew that if he named this planet after the King of England, he would get a lot of money. And so that's what he did. He named it George after King George. And so for many, many years, this was the planet George. Until other astronomers decided that they weren't okay with this because King George wasn't their king. And so they renamed it Uranus, which is one of the Greek gods and fits the theme of the planets being named after Greek and Roman gods. So it is this really pretty, almost like this robin's egg blue color, and that comes from methane in its atmosphere. Methane absorbs red light and reflects blue light. And you can also see that its stripes are moving more, this way instead of this way, along kind of parallel to its orbit. And that's because the planet itself is actually knocked over on its side. We're not 100% sure how it happened, but most likely is it literally got knocked over by a giant collision. All right, last up is the outermost planet of Neptune. So Neptune also has this really pretty blue color for the same reason that Uranus does. We can see some kind of high up white clouds that sit really high up in the atmosphere. And we also see a storm, just like Jupiter had. This one instead is the Great Dark Spot, because it's a great dark spot. Yeah. And so it's another hurricane. It's not quite as big as the Great Red Spot. This storm is maybe about the size of the Earth, so still, quite large for what we're used to. And we don't know what's happened to it recently. It seems to have disappeared. We don't know if it's actually gone or if maybe some of these higher layers of clouds are just covering it up, but that's one of the things we're still trying to figure out. Unfortunately, studying Uranus and Neptune are incredibly difficult because they're so far away from the sun that we can't see them well from here on Earth, and we've only had one spacecraft that flew past and got close-up looks, and that was Voyager 2 in the 1980s. So it's been a long time. And there's still a lot of questions that we have that we are really going to have to wait for future missions to try and get out there and give us some more clues. All right, I know we are at time, but I would not be me if I didn't at least go and see Pluto. Because Pluto is my favorite, and I love it, and I want to see it. So this is my lovely Pluto. It is now known as a dwarf planet. This happened because it turns out that there are quite a few things out here past Neptune that are very similar to Pluto. And astronomers decided instead of having, 20 planets, they would come up with a new category for the things that were like Pluto. And so that's what they did. And so there is the king of the dwarf planets, because he is the biggest of them all, Pluto, and it's 5 moons. Charon is the closest and the biggest. It's about half the size of Pluto. And then the other 4 are Styx, Nix, Kerberos, and Hydra. All right, so with that, we will make our way back to the Earth, back home, and switch back over to us. So yeah, that is our kind of quick, brief tour of the planets, one dwarf planet, and a couple of moons in our solar system. There's still so much more out there, so much. I mean, it would take a couple hours to get through everything, but hopefully you had fun on our brief little tour. Do we have any questions, Eli?
Nope, nothing in there.
No? All right. Well, if you do have a question, now is a great time to ask. While I give you a little bit of kind of info on our schedule for the upcoming week. So on Saturday, we are doing a show called What Does Your Zodiac Sign Actually Mean? And that's what we'll be exploring, kind of how the zodiac signs, why they started out seeming kind of important, what they meant, tell you some of the Greek stories behind them, and also tell you about how and why they have changed since they originated a couple thousand years ago. And then next week on Wednesday, we are doing a show that I think we're really excited to kind of learn and put together called Doomsday Earth. So it's going to be all about the very weird, crazy, and potential ways that Earth could be destroyed. So yeah, that's going to be a super fun one. And then next Saturday is not October. We're not that far in the year. August 1st, which means we will have our monthly What's Up Tonight show to tell you about the things that you can find up in the August sky. So if there are no more questions, we will wrap it up. All right. Well, thank you everyone so much for joining us. We hope you enjoyed your show. We hope you have a wonderful night, and we will see you again next time.
Mhm.
So, bye everyone.